Let's do some more graphing. So again, what we're looking for is we're looking for solution points, right? What ordered pair can I find that makes this situation true? We find enough solution points, usually 3 and above, then I can establish a pattern, and then I basically can visualize or can see all the other solution points, hence the graph of the equation. All right. So again, I'm going to stick to the point plotting technique. I do think when you guys look at letter A, you're going to think, "Oh my God, this guy's an idiot. Why doesn't he do this? Do it this way." I'll show that way in a moment. But again, since we're learning point plotting, and your way only works with lines, how about we find something that works all the time? All right. So point plotting actually works all the time. It's relatively easy, and all we got to do. Right. So again, I'm only going to generate 3 points. So how about, I let x equals 0, -3, x equals 0, right, and x equal to +3. So let's go ahead and just do those. Again, you should always try a positive, a negative, and a 0. So putting this in, if I let x equal -3 and do the math, right, again, what I'm going to be generating here is a solution point. When my x coordinate is -3, what's the y? And so we'll let the equation do the work. So add 9 to both sides, we get 2y equals 15, divide by 2, and it looks like what we have is 15 halves. All right, so I guess that's like 7 1/2 is our ordered pair. Not a pretty one, but that is what we get. All right, what about 0? If I plug in 0 into this thing, right, that's 0 plus 2y equals 6, divide everybody by 2, and we get y equals 3. Right? And so there would be another data point. Much nicer than the first one, but our data point. What happens when x is 3? Well, we plug that in, right? Do the math. So we get 9 plus 2y equals 6. Subtract 9 from both sides. We get 2y equals -3. Divide by 2. We get -3 halves, or basically -1.5. So I have basically 3 data points. Now, of course, one's pretty easy to plot, right? 0 and 3. So there's where that data point is. When we're at -3, we're at 1, 2, 3, 4, 5, 6, 7, and about a half, right about there. And then when x is 3, 1, 2, 3, we're about 1.5 right there. And so you can see, right, that we do definitely have, let me try to draw it as nice as I can. Perhaps I should get a straight edge out. But there, right, I found 3 of them, but it established a pattern that all the other ones are solution points to this equation, right? That's what a graph is, right? It's a visualization of all the solution points, what ordered pairs solve the equation. So there's your point plotting. Of course, a lot of you are thinking, this guy is a bonehead. Why didn't he just do this? Well, I'm going to do that, right? You guys have probably learned, let's put it in y equals mx plus b. But that's just another way to do what I'm asking you to do, which is to find solution points. Check it out, right? I'll subtract 3x from both sides and get 2y equals -3x plus 6. Divide everybody by 2, and we get y equals -3 halves x plus 3. So this is telling me that the slope is -3 halves, and one of my first ordered pairs, right, one of my first solution points is 0, 3. So that captured it, and then the slope's telling us to go down 3 and over 2, and lo and behold, the graph already has it. So we're finding solution points. However you decide to find those solution points, that's what we're doing. So you use some trick to find it, or you use the good old-fashioned brute force point plotting. It all works, right? Again, we can go up 3 or over 2, and lo and behold, there's another data point. So this works for lines and lines only. All right, very nice trick, very quick trick, if you would, to avoid all the point plotting. And of course, we could also use our graphing calculator, but more on that later in another video. But again, I hope I've established the fact that, again, what is a graph? It's a visualization, right, of the solution points to an equation. So here's our equation, and there's all the solution points. I actually have 5 of them that I know exclusively, but every single ordered pair along this line will solve, make that equation true. All right, so letter B. There's some tricks of the trade. This x squared tells us that we're looking at a parabola. Some of you are probably aware of the vertex formula and all that. So again, it's just another way to create solution points. But since we're learning the point plotting technique, and that's what I'd love to see from you guys for a while, let's go ahead and do the brunt force. All right, so again, I don't really even have to solve for y. If you want, you could. All I got to do is start plugging in values. So how about, again, let me go ahead, since we are expecting a parabolic shape, let me get more data in there by putting in some values. So when I put in -2, that's what my equation will look like. So we get 4 plus y minus 6 equals 0. This is y minus 2 equals 0. Add 2 to both sides, and we get y equals 2 as a data point. If you don't like to do that, yes, you could actually, at the beginning, subtract x squared and add 6, and you end up getting that y equals 6 minus x squared. So you plug it in where you want. All you got to do is point plot and plug things in. That's basically graphing 101. So I'll start from here. So what about -1? Right? Well, that becomes 6 minus 1, and we get a 5. If I put a 0 in there, 6 minus 0 squared, well, that's just 6. If I put a 1 in there, 6 minus 1 squared will give us a 5. If I put a 2 in there, 6 minus 2 squared, 6 minus 4, that gives us a 2. All right, so there's basically my data points. And so let's go graph them. Again, we're expecting to see a parabola, a U shape. So I have -2, 2 on the graph. Right, I've got -1, 5, 1, 2, 3, 4. 1, 2, 3, 4, 5, got it. Right, we've got 0, 6. Right, we've got 1, 5, excuse me there, and we got 2, 2. That's a bad point. That was me just being bad. But if you look at our data, right, they basically form the pattern. It is a parabola, but it actually is going downward. All right, and so again, every ordered pair, right, along this curve, every single one does something special. It makes that equation true. Right, so that's your point plotting 101. More to the story. We'll learn some tricks of the trade like we have for lines. We will actually look for some tricks of the trade for parabolas, polynomials, rationals, but it all boils down to what a graph is in the first place. All you're trying to do is find solution points. You either do it the ground and pound way by plotting data, right, or there's some trick available to help you find those solution points. And that's pretty much it. All right, know how to do it all. Of course, there's also the graphing calculator that just gives instant gratification if we know what we're doing. All righty, so that should cover that. Well, how about we keep moving through the module and learn more.